Myself Nichit, and today our project title is AI-based crop disease detection in arecanut and coconut. And my teammates are Mohammad Wais, Siddesham and Prajwal. And our project guide is Rakshita ma'am, and project coordinator is Supriya ma'am, and our HOD is Dr. Shivangoda GM. Uh, let's come to the introduction. Agriculture plays a virtual role in the economic development of many countries, particularly in tropical regions. Among various crops cultivated, arecanut and coconut hold a significant economic role, particularly in South Asia. However, these crops are highly variated and various diseases which can lead a significant yield losses and impact the livelihood of farmers. AI-based crop disease detection system harmless machine learning algorithms, image processing and computer vision technologies to automatically identify and classify diseases in plants. These systems are designed to provide faster, more accurate and efficient methods for detecting crop diseases, potentially reducing the dependency on human and traditional field inspections. AI can analyze large volumes of data from images, weather patterns, soil conditions, and even horizontal disease outbreaks, allowing farmers to make data-driven decisions and take preventive measures before the disease spreads. And we made a literature survey. In this literature survey, the title of the paper is Technological Advancement in the Arecanut and Coconut Research in the year 2022, and the author name is Prabhakaran Nair. The technology adopted is soil moisture sensors and satellite imaging. And the second paper is basal stem root disease of coconut and arecanut in India in the year 2020, and the author is Kirtana Jayarajan. The technology adopted is molecular diagnostic kits. And the next paper is present scenario of diseases in arecanut in the year 2021, and the author name is S. Raghu, and the technology used is mobile apps. And the next paper is pathoparia diseases in arecanut in India in the year 2022. Author name is H.P. Maheshwarappa, and the technology adopted is loop mediated isothermal amplification. And let's come to the problem statement that technological methods for detecting crop diseases in arecanut and coconut are often time consuming, labor intensive and the human error leading to deployed diagnosis and ineffective treatment. Diseases such as arecanut white, yellow leaf disease, budroot and leaf white can cause significant yield losses and economic damage if not identified and treated promptly. In lack of timely and accurate disease detection results in increased use of chemical treatments, higher loss and environmental degradation. AI-based crop disease detection prevents a promising solution by machine learning, image processing and predictive analytics of accurately identify diseases at any early stage, enabling farmers to take immediate action and minimize the crop losses. Thank you.
Good morning to everyone. My name is Mohammad Wais and my topic is detection of arecanut and coconut disease. And my topic is objectives. First one, there are three types of objectives in our project. First one is develop, second one is design, third one is implementation. First one, we can see the first one, develop an automated crops disease detection system using the machine learning and the image techniques, and user friendly also, and mobile or web based platform for the farmers to easy upload the images, scans or received the diagnostic result. It's received the diagnostic result. And second one, you can design AI based model capable to identification and the classification of the crop disease from the images with the high accuracy and the integrated system that combines and the algorithms that can improve that accuracy through the continuously learning from the new data. And third one, we can see the implementation, how we can implement the crops disease detection system in the field trial to evaluate that its an effectiveness under the real farming condition. a training program for farmers on how to use the detection system and interpret the results. It shows the how to crop the photo and how to we can upload the photo. And next one, the scope of the project. The scope of the project for AI based crop diseases detection in the arecanut and coconut involving the development and the integrate system that can be accurately identify and the classification crops of the disease using the images and the progress of the machine learning techniques. And the second point, we can see this project aim is to address the challenges faced by the farmers due to the delay or incorrect diagnosis for the plant diseases, and which often lead to significant yield losses. And in second point, we can see the how can farmers the facing the problems about the yielding and the crop diseases. And third point, by collecting and analyzing the large data set of the plant images, both healthy and diseased, the system will be trained to recognize the common diseases such as the yellowing leaf and the other diseases also present in the arecanut tree. The bud or the root or the mint of the infestance in the coconut. And the third point, we can see the solution will be implemented through an user friendly mobile or the web application, and allowing with the farmers to capture and upload the images of their crops and receive the instant feedback on the diseases and identification and recommended the treatments. In our website, we can instantly show the feedback how it is how which disease it can be under, and the farmer can be automatically receive the instant feedback from our website. And next is the system will support the local languages and be designed to function and low connectivity in rural areas. We can see that in many rural areas there are low network connectivity, and we are ensuring the accessibility for a small and micro farmers. In the long term, the project may the integrated additional techniques. And in the arecanut, we can see the in our taluk is Changiri. In our taluk, there are 90 to 95% of farmers growing the arecanut, and arecanut is used for many factories and many other medicines. And in today's rate, arecanut is a 530 rupees per kg. And this is one of my small presentation. And next, continued by my friend.
Hi everyone, my name is Prajwal. As my friends discussed above, they discussed about the AI-based crops disease detection, about introductions and the objectives and scope. Now let us see about the methodology. The first point is data collection, visualization, observation. Farmers or agronomists inspect a crop for signs of the disease such as discolored leaves, wilting, spots and lesions. Remote sensing, drones or satellites equipped with the high resolution cameras or multispectral sensors capture imagery or large crop fields. This helps in monitoring the plant health from above. Environmental sensors, by using the temperature, humidity, soil moisture and other environmental parameters are monitored as they influence disease spread. And some farmers can use mobile applications like apps. They can use apps to take pictures of the crops and upload them for further analysis. The second point is data pre-processing. In this image processing, the farmers can collect the raw data about images, videos or satellite data is processed to remove noise and improve quality for disease detection. This step includes the enhancing image resolutions, reducing the cluster and segmenting areas of interest. Third point is about features extraction, like color features. Change in color, for example yellowing or browning of leaves can indicate the diseases of arecanut and coconut. And texture features like pattern like spots or lesions can be quantified by analyzing the textures of leaves or crops. And in some shape features, The feature of the shape of the plant, for example, deformed leaves can help to identify certain diseases. Spectral features like multispectrals or hyperspectral imaging allows for analysis of rectangles from different wavelengths, which can differentiate between healthy and non-healthy crops. Fourth point is about data detection, disease models. Machine learning, supervised and unsupervised learning techniques are applied to extract the features. Algorithms like random forest support vector machines and neural networks can classify the crop condition as healthy or diseased crops. Deep learning, conventional neural networks are increasingly used for image-based decision detection because they are excel in recognizing the complex pattern. Anomaly detection, statistical method or deep learning models can identify the deviation from normal growth. Fifth point is about the disease classification, like diagnosis. After detecting the anomalies, model can classify the disease based on symptoms such as powdery mildew or blight and rust, etc. Severity estimation. Some models can also predict the intents of the disease spread by estimating the percentage of the affected area. The last point is visualizations and reporting. Disease mapping. For example, geographic information systems or farm management software can map the areas with potential disease outbreaks, helping the farmers to identify the hotspots and focus the treatment efforts. Decision support. Information is delivered to the farmers or agronomists via dashboards like mobile apps or web platform, which actionable insights such as to need for pesticides applications or irrigation adjustment. Now let us see about the flowcharts. First, our project is about to start and capture the image of the crops, leaves or some crops. Next, image pre-processing. The further step is image post-processing, and our software is detecting the disease classification and grading, and finally analyze the which crop disease is occurred.
I'm Siddesham. I'm going to explain about hardware and software requirements. The software requirements are operating system, developing environment, fortunate technology, and backend technologies is Python, SQL, and PHP. Hardware requirements are basic development machine CPU, quad-core processor 1.8 GHz or higher. RAM is 8 GB minimum. Storage is 15 GB SSD. The expected outcomes of our projects are successfully development for reliable and arecanut model that can identify major crop diseases at early stages using images analysis. The system should be able to classify different diseases such as like yellow diseases, bud rot and pest investigation with high level of accuracy. Ideally over 90% as a user-friendly mobile application for the available farmers, enabling them to upload images and receive instant academic feedback including disease identification, severity assessment and treatment recommendation. The solution should support multiple regional languages and function effectively even in the areas with the limited internet also. Next is references. The technology's advancement in coconut, arecanut and cocoa research a century of service the global farming community by the Sentinel Potential Crops of Research Institute of A. Koropakanar Noyer Kodon Prabhakar Nair tree crops harvesting cash from the world's important cash crops. The basal stem diseases of coconut and arecanut in India present status challenges green Kirtana Jairajan Dayamal V.H. Prabhavati Vinayak Indian Pathology. The coconut and arecanut production protocol under the urban climate of coastal region also. The present scenario of diseases in arecanut and nut beetle nut and their J. Raju K. Jayalakshmi Preeti Sonavin and S. Raghu diseases of arecanut crops diagnosis and management. The python disease of arecanut in India feeding present status and future prospectus Patel and Hegde Vinayak and H.P. Maheshwarappa and H.V. Swami Indian Pythonology.